Awesome. Hello, everyone. My name is Tom Cronin. I'm the head of data science and data engineering at Lloyds Banking Group. Thank you very much for sticking with us to the afternoon. It's the hardcore crowd still here. And also, if hopefully you can all hear me all right. Just wave if I'm mumbling or anything. But so what I'm going to talk to you today, I'm going to run through 4 different things. So first of all, I'm going to give you a bit of an insight into who we are as Lloyds Banking Group and as a team. I'm going to touch very briefly on what is data science, because data science is many different things to many different people, so I'm going to talk about what it is to me. I'm then going to spend most of the presentation talking about what I like to call the road to responsible AI, to give it a very snazzy title. Ultimately, this is a way of saying, these are all the mistakes I've made, please don't repeat my mistakes. And at the end, I'll just summarize it up as that. So, number 1, who are we? I promise this is the only slide with words on it, or a large number of words. But for any of you who aren't from the UK, you might not be aware of who Lloyds Banking Group is. So Lloyds Banking Group is a collection of banking brands, and to summarize it very briefly, we hold about 1/3 of the UK's retail banking population. So the only thing really to pay attention to here is we have a lot of data. We have a lot of data and a lot of customers and a lot of transactions happening. And so I suppose one thing you all might not necessarily think about when you think about Lloyds Banking Group is you probably don't think, oh man, I bet they're a cool AI tech company with loads of sweet innovation. And I couldn't blame you at all for thinking that, to be honest. But one thing I like to reflect on a lot is that Lloyds Banking Group's actually had quite a long history of technological innovation over the 300 plus years that it's existed. Some of that might not be particularly exciting today, but back in the day, things like cash machines and even paper banknotes, money on paper, crazy. Imagine that. So we've had a long history of technological innovation. And that is something that today we're driving forward very strongly right now. So what part of Lloyds am I from? So Lloyds is an enormous organization, 70,000 people. For context, turns out that there were 2 other people from Lloyds talking today, and I didn't even know they were talking. So that's how huge we are as an organization. But the part of the bank that I'm from is something called the Machine Intelligence Program, which exists within what we call group transformations. This is a centralized change function in the organization. And So we consist of a bunch of different labs. So the first lab is robotic process automation. We also have our digital products lab, which is essentially building various bits of like quick AI startup, quick little apps. We have our intelligent products lab, which is focusing mostly on things like natural language processing, things like that. We have our new and upcoming customer DNA lab, which focuses on how do we get the most out of the very rich data asset that we have as an organization. We have an enormous amount of rich data, and there's loads of different ways we could use that to help our customers. We have our virtual assistance lab, and the virtual assistance lab focuses mostly on kind of cognitive services, so things like the chatbot. If any of you are Lloyds Bank, Halifax, or Bank of Scotland customers, you can go into the app, you can chat to a bot that was made by us, which is pretty fun and pretty cool. And it's very fun to swear at it and like try and trick it with various things. Great fun. But the coolest bit, the best bit, obviously, because it's my bit of the team, is what we like to call the data science team / machine learning lab. And what we're all about is building a kind of centralized data science function that focuses on building all sorts of models, machine learning and otherwise, for various parts of the group that may not have had AI products in the past. So let's now do some sweet animation, the likes of which Pixar have never seen. Oh my God, I built it up for nothing. Never mind. Right, so what does a standard feature team look like? Just to give a little bit of flavor as to how we operate. So in general, we have a whole bunch of data scientists. We have a group of graduate data scientists. We just had a cohort of 15 specialist graduates join, which has been very exciting. Otherwise, we split into data science and data engineering. The reason for this being that we have a lot of data scientists who specialize a lot in things like statistics, and then we have a lot of data engineers who specialize a lot in things like pipelines and good quality good data management. And the rest of the team generally tends to look more and more like a kind of agile delivery team, to be honest. So we tend to have a lead data scientist who's frankly someone with scars on their hands about mistakes they made in the past. We use delivery leads and product owners, and the most important, the unsung heroes, being the business analysts. So people from the part of the organization that you're actually trying to build a model for, because as a data scientist, like if I bring it to life, Last year, we ended up building a product within commercial asset finance, which is all about leasing fleets of vans. And unsurprisingly, I had no goddamn clue what is the most predictive thing about why you might want to lease some more vans today. But a business analyst is very powerful in helping you define that. So, bit of a flavor of how we operate. But then I know, like I said, to many people, data science is a different thing. So what do you do when you're trying to look for the definition of data science? You Google it, and you go straight to Wikipedia, and Wikipedia gives you, frankly, quite a vague answer of what data science is. So it basically, the short version of this is data science could be basically anything. But to me, this is my very non-exciting diagram of what data science and particularly machine learning is. Machine learning is nothing more than pointing an algorithm at some data so that it can create a model, which is a set of instructions, and then applying that set of instructions to some new data, and in doing so you make predictions. It literally is as simple as this. You can boil down any machine learning algorithm, any machine learning application into this. Maybe with many different copies of all of the squares, but this is basically it. So whenever I talk about machine learning today, I'm going to keep this is what I'm keeping in mind. So with that in mind, I'm going to move on to, as I say, what I like to call the road to responsible AI. So over the last 2 years, so the team I run has gone from 3 nerds sat in a corner to a team of about 70 people. And in doing so, we're now becoming much more, the group is becoming much more dependent on the tools and services that we're building. And so anyone who's been through this kind of rapid scaling is probably familiar with the fact that it's very easy to make lots of mistakes rapidly and have them grow wildly out of hand. So please consider this as Tom's personal group therapy session to share all of the things that I've learned over the last couple of years. So the first thing I want to talk about is around, I guess how I describe it is ambiguity. So one of the biggest problems as a data scientist is usually you end up being faced with problems that you've not necessarily tackled before. So maybe you've just joined a new organization or even in a new field, and you're expected to very rapidly be able to quickly build a model, quickly generate some value for the organization. And so to demonstrate, I suppose, the potential pitfalls and danger of this, we're going to play a little game. That's right, there's a very small amount of audience participation. Everyone stop groaning. It's going to be great. And before we get started with this, I have to give some credit. It's somewhat adapted from a presentation I saw by Cassie Kozrakov a couple of years ago. So any of you got the chance to see her this morning, I'm very jealous because the queue was too big. Couldn't get in. But what we're going to do, I want everyone to put yourself in the mindset of pretend you're all robots. You're all robots and you're all built with one singular purpose. You were designed to answer one question. Is this a picture of a cat or is it not a picture of a cat? That's as simple as it is. You don't care what the picture is. You were programmed your entire life to understand, is this a cat or is it not a cat? And what we're going to do, and we are going to do this, or I'm just going to start rambling, and I'm going to make sure the doors get locked so you can't leave. I'm going to say 3, 2, 1, and everyone's going to say cat. So we're going to go 3, 2, 1, cat. Or we're going to say 3, 2, 1, not cat. And as I said, I really am not going to move on until we play this game. It's going to take about 30 seconds. So let's do a quick practice. So 3, 2, 1, cat. There we go. That was good. Thank you, everyone. Okay, let's do it. So I'm going to say 3, 2, 1. I'm going to change the picture. So 3, 2, 1, cat. Loud. Come on, louder, or we're just going to keep playing. 3, 2, 1. Not cat. Not a cat. Obviously not a cat. 3, 2, 1. Cat. You can see it's pretty easy, right? 3, 2, 1. Not cat, not cat. You guys are good at this. You were trained very well. 3, 2, 1. Cat. 3, 2, 1. Okay. A lot of people didn't answer that time, and there was a little bit of dissension at the front. So, who here thinks it's a cat? Anyone think it was a cat? Yeah, a bunch of people say cat. Who doesn't think it's a cat? A lot of people say not cat as well. So, for me, this was a really great example of why it's really important to understand specifically what the problem is you're trying to solve. So at the start, I said you were designed to tell if this is a cat or not a cat. I didn't tell you why. So if you're an algorithm built by, let's say, London Zoo or any other zoo to point a picture and like teach children what kind of animal it is, hey, you know, this probably is a cat. It's part of the cat family or whatever it's called. But if you're part of some kind of automated drone delivery company that delivers pets to small children and the child says, I love cats, and you delivered this, could be slightly disastrous. So to build on the image I had before, the most important thing you need to remember when you're building any kind of product, whether it's AI, machine learning, anything, even if it's basic analytics, what is the action that you're going to take off the back of it? And your action should drive every single decision you're going to make. And I'm not talking about necessarily how you implement it. I'm talking about what is the physical action that's going to affect either the colleague or the customer. So, or as Cassie Kozakov much better put it, the objective is subjective. Make sure you bear that in mind. Super important, and a mistake I've made over and over again. So, the second thing, and I'm sure any of you who have worked in AI or ML for any period of time have come across at least someone who totally doesn't understand what artificial intelligence means. And they associate it with building robots or taking over the world or whatever. But to be slightly less flippant about it, most people tend to associate it with things like job loss. And we were talking earlier at the AI panel about whether we think AI is going to lead to a job reduction, job increase. And in general, there's kind of two schools of thought on this. So a lot of people refer to what they like to call the Luddite fallacy, which basically says, look, as a society, we've always adapted to reflect the technology we have at the time. So back in like 1900, when the car was invented, everyone was walking around saying like, but what about all the horseshoe makers? What about all the saddle designers? The society's going to collapse overnight. But it didn't. It created a whole new industry of automotive engineers. And frankly, that's where I see the world of AI going as well. But aside from that, there's also another side to AI which often invokes a little bit of fear or uncertainty, is frankly around when AI is surprising. No one wants to be surprised by an algorithm they've designed. And I suppose another way to think of that is creativity. So one thing you don't want, if you're being operated on by a robot, you don't want that robot to suddenly get creative and try something different. And it was when I was thinking about this that I started to think, well, what actually is the definition of creativity? Like, at what point could you really say that my stupid logistic regression model, is that smart? Is that creative? Does it have to be a neural network? Does it have to be a deep learning framework? And that kind of led me to this definition of creativity by Margaret Bowden. And she posits that creativity is defined as something that's new, surprising, and has value. So this picture I was on before, this is what's known as Google Deep Dream. Essentially, it's kind of like a deconstructed ImageNet. So essentially, rather than using an ImageNet to understand what the picture is, you basically tell the ImageNet, just keep amplifying the picture you're looking at until it looks like the weights in your neural net. And you start to get all these really wacky shapes. And you could describe this as art. You could describe this as being creative. And to this definition, it's certainly new. I've never seen anything like it. It's surprising. I didn't realize it was a thing that could exist. Whether it has value is slightly more subjective, though, because how do you value art? I don't know. But to use another example, and this was very, very well documented a couple of years ago, when Lee Sedol essentially lost to an AI system at the game of Go. And I believe there's a documentary on Netflix all about it, so I won't spend too long talking about it. But ultimately, for anyone who doesn't know, the game of Go is very different to playing chess. In a game of chess, you can literally just simulate every possible move, so it's a solvable problem, essentially. In the game of Go, I think there's enough possible moves as like atoms in the universe. So basically, it's impossible. For all intents and purposes, it's impossible to solve it as a computer system. And so 2 years ago, everyone was saying, like, you know what, this probably won't happen. Maybe it'll happen in 10 years, but forget about it. But 2 years ago, Lee Sedol, who was the Go champion at the time, he was defeated. I think he lost 3 out of 5 games. I think I'm not 100% sure. But there was a really critical moment that was very well documented. I think it was called Move 37, and Move 37 blew everyone's mind in Go circles. So essentially, what happened was the guy who was playing for the computer put a piece just like way on the opposite side of the board, and everyone was looking at it like, what the hell's going on here? The computer must have totally screwed up. Game over for the computer. This is all a big waste of time. And Lee Sedol was slightly baffled by this, but eventually sort of brought himself back together, kept playing the game. And long story short, by the end of the game, the computer had won. And ultimately, what Lee Sedol said at the end of this whole process was, it was actually that move that basically triggered the rest of the game to fall in the AI's favor, because he was constantly on the back foot. And so to me, that move that came out of nowhere meets the definition of creativity. I would argue that that AI system was being creative. It tried a new strategy that had never been done before. It surprised the bejesus out of everyone, and it clearly had value because in the limited purpose it was doing, it won the game. So is that AI being creative? I would argue probably yes. So what can you do about all this, I suppose, is the other question. So there's a lot of people who are scared, a lot of people want AI. These are kind of the three things that I think are most important into like how do you deal with this situation. So the first one seems really obvious. It's just education. It's teaching people about what AI is, what ML is, what data science is. A lot of your business executives don't really understand what data science is. You really need to hold them by the hand and teach them about this. You need to teach them about what it means to operate in a world of statistics and uncertainty. It's a very different world. Something that will help with that is explainability tools. A lot of these models are scary black boxes, and a lot of people have spoken today about the dangers of black box models. I'm sure most of the vendors in this room sell products around model explainability, but explainability tools are really useful. Like things like Lime and Shap have their place in helping you understand how your models operate. And finally, the most exciting one that everyone loves is controls and governance, because good governance is the start of everything great in this world. So I come from a credit risk background where we're totally regulated to hell and back, but AI is something that we're seeing a lot of new tech companies who are building a lot of slightly dangerous and worrying AI systems at a scale we haven't seen before. So I honestly think like a robust approach to regulation in this space is really important. And the EU's published some guidelines quite recently. The UK government's doing the same. It's going to be really interesting to see what happens in this space. And the main reason I'm excited about this is I don't want to end up in this situation. So this is probably every data governance guy's worst nightmare of being dragged in front of the select committee or whatever it is, I think it's Congressional Representatives House or whatever. And it brings me on to my kind of third lesson. It's something that I really wish I'd spent more time learning about at the start. So this is all around data ethics and unconscious bias. And again, a few people have spoken about this today. But I want to kind of share my thoughts on this. So it's been, a lot of these examples have been really widely documented as like, so I think I've heard 4 presentations today use the Amazon example. So I'll focus on some of the other ones. But like, I think this was back in, maybe it was like 2007. I think it was one of the very first HP image recognition systems. They released a face unlock technology, and now face unlocks on basically every device we have, but 10 years ago it was quite rare. It was a brand new thing. And this video went really viral because essentially it would successfully unlock her face but not his face. And so obviously it got the title of HP Computers Are Racist. And for me, this is a really, really great example of why, as data scientists, we need to be very careful with what we build, because I don't think for a split second that the 5 or 6 data scientists who built that algorithm sat down and thought, let's build a racist unlock tool. Let's do it, guys, because why not? Let's be racist. But what they probably did is they probably spent the vast majority of the early development testing it on their own faces, testing it on image databases, which do mostly consist of white male faces. So something that they should have done is spent more time thinking about the potential impacts of the model they were building. And that might have led them to decide to, reweight their model on certain like less representative classes, etc. So Joy Buolamwini leads something called the Algorithmic Justice League, which is the coolest name thing ever. And she's written several papers about exactly this and how this kind of discrimination is actually quite prevalent in quite a lot of industries. And so for me, like, as a data scientist at Lloyds Banking Group, like Lloyds Banking Group represents a third of the UK, the last thing I'd ever want to do in a million years is inadvertently build a tool that is discriminating against some of our customers. So I suppose the question you have to ask yourself is then what the heck can you do about this? This is a really hard problem to solve, and I honestly don't have a silver bullet answer for this. But the things that I've learned is thing number one is you really need to put an active focus on diverse recruiting, diverse talent. And by diverse, I'm talking about everything from like age, gender, nationality, everything you can think of. The more diverse your team, or the more the team you have represents the society that you're trying to build products for, the less likely it is that you're going to inadvertently build something with some kind of unconscious bias built in. As I said, it's not a silver bullet, but this will help a lot. And honestly, it's one of those things that, as someone who's done a lot of recruitment recently, a lot of people kind of shrug and say things like, yeah, but there aren't that many women in data. It's mostly guys. So what are you going to do? And it's like, well, if that's the case, you need to spend some effort into attracting the right kind of talent to your team. And the second one, elephant in the room, you've just got to talk about it. Like, this is one of those things that people are terrified of talking about, gender discrimination. Like, the idea that you build a credit scorecard and someone would walk in and say, how do you know this doesn't discriminate against women? Everyone probably go white in the face and say, oh, I don't know, it probably doesn't. But the thing is, we have to be a lot more confident in pulling some of this highly sensitive data and actually understanding the products we build. I'd much rather we do extensive analytics using things like gender and age to make sure that we don't build models that discriminate unfairly. And so the final thing I want to talk about, which it actually ties it quite nicely to the previous presentation, anyone who was here, it's all about, I guess, the challenge we've had in working together. So I'm from a very large organization that's growing very quickly, and working together is really, really challenging. When you have all sorts of disparate tools, ways of working, mindsets, it's very easy to get into, well, frankly, what I love to refer to as the infinite loop of sadness. So the infinite loop of sadness goes something like this, and I'm sure a lot of you will, I don't know, you'll recognize some of this stuff. So in general, you tend to have data scientists, and all data scientists want to do is they want to build cool models. They want to build sweet deep learning models that they can put in their GitHub repository and brag about it on Stack Overflow. Meanwhile, you've got data engineers who just want to build the most amazing real-time pipeline you've ever seen. They don't really care what the data science actually want. They just want to build a sweet pipeline. Meanwhile, you've got the ops team who are sitting there thinking, why is everyone using all our infrastructure? Why are we running up so much cost? Wouldn't it be better if we just did nothing? And then you've got the business who are wondering why none of this was done like 5 minutes ago. And you end up in this never-ending cycle of like people blaming each other. And it's horrible. And the thing is, this is prevalent everywhere. Anywhere you have a world where you all work in separate teams, there's going to be some level of this, some level of bickering between teams. But the things that I've learned, the most important things to do is to build strong bridges and create blended teams of all of these skill sets. So one of the things we did last year is we integrated the data science and data engineering team. So I'm now the head of both of these teams, and almost within about a month, the what was previously a very big tribal gap of data science, data engineering just became, we're just one team trying to solve problems. And we're doing more and more of that with our ops team. So our current data science platform was built within our lab, within our team, because we are the main customers. And every day we build closer and closer relationships with business. So this is really important. And I suppose to bring this to life, so Google published a paper on scaling machine learning, probably like, I don't know, 5 or 6 years ago at this point. It's a very interesting paper. But the best diagram on it is this one, which just represents the tiny little black box in the middle is your machine learning code. That's your model. You have to bear in mind that every single thing you do as a data scientist is in the context of a much wider project. You are just a cog in the machine. As a data scientist, you are not God walking on this earth. You are working with your peers to build a wider system. So, I suppose to summarize on that, so I recently, most of you probably have heard of XKCD, but I went to Randall Munroe's book signing not that long ago, and he talked about what his favorite comic was. He said his favorite comic is this one, because it reminds him of how he likes to operate, and every day he loves learning. So he wrote a whole book recently that's all about, frankly, mad ways to solve problems. So he had to learn so much for it. And he said he loved it because for him, learning is the most important thing we can do. And one of the things that comes up quite a lot, particularly in the data science world, is you get a lot of people that are a bit afraid to say things like, oh, I don't actually know what Apache Spark is, now that I think about it. People say it a lot. Or Kubernetes, what's that? People say it a lot, don't know. And he reflected a lot on the fact that every day, 10,000 people a day are learning about something for the very first time. So one of the things that we really tried to instill in our team is this culture of like honesty and learning. And if you ever get to the point where someone says, I actually don't know how this works, I don't know how GitHub works, like just take that as like a bit of a blessing, like, hey, I get to be here when you learn that for the first time. That's kind of cool. I get to teach you this. So I suppose to summarize then, what have we learned? We learned 4 things. 1, define your model by its actions. Cannot stress this enough. What are the actions of the thing you're building? It will define everything else. You can allay fear mostly through education. Education is definitely the place to start. There's not that much to be worried about, really. Most of it isn't new. It's just amplified. So through education, you can allay a lot of fear. You need to mitigate your unconscious bias. You'll never get rid of unconscious bias, and you should never try to get rid of unconscious bias. Unconscious bias is intrinsic to who you are as a person and a personality, but you need to understand how to mitigate it through working with a good, diverse team and understanding the potential impacts of what it might be. And finally, be humble. Models aren't everything. A lot of people walk around thinking they're super cool. Hey, I want a Stack Overflow contest. I'm awesome. I'm walking around like, I really don't care. I couldn't care less. The model is a small part of the overall system you're building. If data engineering is 80% of it, your little model is, I don't know, 5% of it at best. And I think that is everything from me. So thank you very much for listening, everyone.